Okay.
Luis looks like Bruce Wayne, and you're over here like the person photobombing.
All right. Okay, so let's look at the problems that we have today. We've got something similar to what we've been doing with solving differential equations, but for these we'll be finding particular solutions. So everything we were finding so far was considered a general solution because it still had the plus or had the C value in there somewhere. So it could have been actually infinite number of solutions. So we are going to solve these differential equations, and then it gives us a particular value that we are going to use to to find what that C value should be. All right, so we've got dy over dx equals y squared minus xy squared. And then our initial condition is y of 3 equals 1. So we have to solve this differential equation first. And whenever I look at this, what do I need to do so that I have to get my variables separated. All the y's on one side, all the x's on another. Okay, so yes. So it'll be x squared, y squared.
What? That's all it is?
Well, not yet. That's the first step.
No, I mean like that's what x, y squared is.
Yes. Okay. If it was x plus y, we'd have to square, double square, but those are just multiplied together. So what can I do now? Yeah. The way I was thinking of doing it is what Logan said, and I was thinking of factoring out a y squared. So it looks like this. But it would be okay to divide everything by y squared. Also, that would work. So if you are thinking of it like this instead, where you're dividing by y squared, that's okay too. It's going to have the same result. So if you do factor this out, you can multiply both sides by dx, because you don't want that dx in this bottom part. And then you would divide by the y squared, unless, of course, you did that first. It's really important on these, you have to have the dy and the dx. If you don't write those dy and dx's, they're not going to consider your variables separated for that. Because we have all of our y's over here. So you told me what I did in green. You could either divide everything by y squared here, which was a suggestion, or you could factor it out and then divide it off. It doesn't really make a difference which way you do it there. Okay, questions so far? All right, once we get our variables separated, we have to integrate both sides. How do we integrate that dy over y squared? Dy will go away. The y's do not cancel. I think. Let's see. All right, so I was waiting for somebody to say natural log, but nobody was saying that. But you don't use natural log for this, because when you have a denominator for that, my students usually want to do a natural log, because we use the natural log pretty often when we have a denominator, but if you have an exponent of 2, I like to just think of this as y to the negative 2 dy. So that would be y to the negative 3rd. You would divide out front by that negative 3, so you get negative 1/3. Oh, yeah, you're right. I'm sorry. Thank you. No, I make too many mistakes whenever we're doing this. And then over here, when we integrate, we'll get x, and then we'll have x to the 3rd. We'll divide out front by 3, so we'll get 1/3, and we'll put the plus c right here. Yes, you have to put the plus c, but we need to find what the c is. So there's going to be more steps after this. All right, so I would probably write this as negative 1 over y equals x minus 1/3 x cubed plus c. You have some options. You can see all of the answer choices are solved for y. So we could solve for y at this point, or we could find the c first and then solve for y. It really does not matter which one you do. Let me see if there's a way I think that's easier. Let's see, y of 3 equals 1. I don't like y of 3 equals 1. Let's find the c first, I guess. So we've got y of 3 equals 1. We've got the point 31, I think. I don't like it when they use y of 3. I'm pretty sure that's right. I'm going to check my answer on this one. All right, so we're going to plug in 3 and 1 into this equation, and that will allow us to find the c, because c will be the only variable left. So I have negative 1 over 1 equals 3 minus 1/3 times 3 cubed plus c. So we got negative 1 equals 3. Let's see, this is going to be 9 plus c. So negative 1 equals negative 6 plus c. Add your 6, and your c is 5. Okay. All right, so we have this equation now. All of our answer choices are solved for y, so we're going to have to solve for y. I'm going to multiply both sides by y. Yep. And then I'm going to divide.
Is this an example of a long one or an average? Because it's doing this in a million.
These are more commonly found on the free response section than the multiple choice. So this would be fairly long for multiple choice, yes. But now this is pretty average for what you'll see on the free response. Usually it is all together in one part, and that part is worth like 5 or 6 points for that FRQ. They usually will say, we'll see on the next problem how they word that, but they usually ask you to solve for y. So you would have to do this. So you would have y equals -1 over x minus 1/3 x cubed plus 5. Now, on free response, it'd be okay to leave it like this, but it is not an answer choice.
And then you just guess.
There is a correct answer. No, there's a correct answer.
You send it on B. I'm gonna say it's on C.
Okay, B is correct.
I knew it.
How do we get from our answer to B?
You send it.
Just multiply the top by 3 and the bottom by 3, which is okay. It gets rid of that 1/3 that's there so that you don't have complex fractions. And if you do that, you got -3 over 3x minus x to the 3rd plus 15. So B would be the correct answer there.
So on the final, how many FRQs did you do?
6.
6?
6. You have an hour and a half for 6. Sounds like lots of fun. All right.
Is it our midterm supposed to be?
Yes, we're going to do Thursday and Friday. We're having a super midterm.
Marathon.
Yes. All right. Questions on that first one? Okay. Here's an example. This is a full free response question like you will see on the AP exam. So it's going to ask you, some stuff is going to be particular solution. Some of the stuff is a little bit of review, but I wanted you to see the whole thing. Because most years there is a differential equation free response question. Most years there's one where you're going to have to solve a differential equation. So this first part is not asking us to solve the differential equation. It is asking us to sketch the slope field. So to sketch the slope field at the 9 points indicated, if you want, you can just make yourself a chart. So at 1, 0,
What about 0, 0?
you're only going to do the places where they have those black dots. So you would only do those places that have the black dots. So you will not do 0, 0. So at 1, 0, you would have 0 minus 1 over 1, which would give you -1. So you draw your little line with a slope of -1. At 2, 0, you would get, in the top you'll have 0 minus 1, which is -1 over 2, so you get -1/2. So it's still negative, but you need to make it a little less steep. And then for 3, 0, you're going to get -1/3. So still negative, but even a little less steep than the one before. Okay. Then we're going to do the next row. We'll have 1, 1, which is going to give us 1 minus 1 is going to give us 0 over 1. So we get 0. And then it's going to happen for all of these at 2, 1, you're going to still get 0. And at 3, 1, you'll still get 0. So you're going to have horizontal slopes there. And then we've got 1, 2, which is going to give us a +1. 2, 2, which is going to give us a +1/2. So less steep, but still positive. And then 3, 2 will be 1/3. And so that'll be a little less steep here. When they grade these, they grade them in relation to the other slopes that you have drawn. So you would get, usually it's 2 points on something like this. You get a point for getting your zero slopes right, and then a point for your other slopes. So as long as you've got negative slopes here and they're at least looking like they're a little less steep, and positive slopes here and they're looking like they're a little more or a little less steep there, then you'll get the points. They're not going, they don't have to be super precise. Okay. All right, questions on slope field?
Do you think
Is it 2/3 or 2 300?
This is 2 with 3 underneath.
so?
Yeah.
Slope fields, when you're answering them, it's kind of like a free response, but with the lines, right?
Yes. These are free response. This will be on free response
Would
section.
it help for the grader if we made a graph, or what do you?
You mean the table?
Yeah.
No, it doesn't matter. So if you prefer to do this all in your head and you can keep it straight, you don't have to make that table. I sometimes get mixed up,
Yeah.
so I usually, especially in high stakes situation, go ahead and write it. But
I think I'll probably do that, because easy question like that, I wouldn't want to miss.
yeah, these are pretty straightforward problems. So if you get one of these, just be careful because it's easy to make a mistake where you're doing so many points. Okay. All right, so let y equals f of x be the particular solution to the given differential equation with the initial condition f of 3 equals 2. Write an equation for the line tangent to the graph of y equals f of x at x equals 3. Use the equation to approximate the value of f of 3.3. All right, so let's talk about what we're doing for part B. They're saying y equals f of x is the solution to this differential equation. So this differential equation is our derivative. Y equals is the solution to that. So if we integrate it and solve, we get the solution. But what are they asking us to do?
Approximate
Tangent line, and then approximate using that tangent line. So you're actually not solving this differential equation on the step, right? They're telling you that this is the solution, but you're not solving it. Because they tell you f of 3 equals 2. So that is your point of tangency. How do we find the derivative?
You gotta find.
What is the derivative? Very good. dy dx is your derivative, y minus 1 over x. You don't necessarily have to write that, but you do need to write this, dy over dx. At that point, so to the notation for that, and you need to write this, dy over dx such that xy equals 3, 2 is going to be 2 minus 1 over 3, which gives us 1/3. That is our slope. So that derivative is, or that dy dx, that differential equation, that is your derivative for this particular solution that we're talking about. So if I've got my point and my slope, I'm going to write my equation of tangent line. You don't have to label this, but it doesn't hurt. Helps the grader understand that you know what you're doing. And then they ask us to use this equation to approximate f of 3.3. So how do we do that?
Plug it in.
Just plug it in. And when you do this, you need to label it. So you need to say f of 3.3. You need to use the squiggly equals, although they might have mercy on you if you don't. But it's an approximation. It doesn't equal this exactly. And then we'll do 3.3 minus 3 plus 2. Technically, you can stop there. You do not have to simplify that any further because you don't have to do the arithmetic at the end of an FRQ. Somehow I just can't stop myself sometimes.
I know it's annoying when it's like that.
I know. So I would probably do 1/3 times 3/10 plus 2. The 3's will cancel. You get 2.1. But it is a lot safer. I don't like doing it, but I promise you that it is definitely okay to leave it like that right there. Because if you make a mistake in doing that, you're not going to get the answer point. Whereas if you just leave it right here, then you get the answer point. So, but I don't like doing it like that.
What if you do that work with still circle the equation?
Mark out the other stuff.
Yeah, if you mark anything out, they will not grade it as an answer. That's one reason I would really like to be a grader, is so I would know, like if you circle something.
Like you work it out.
Yeah. There's different schools of thought on circling answers or not. The lady that did my first training that I ever went to, she said to tell students never to circle your answers. Because if you don't circle your answers, you have the correct answer there, but then you did something else wrong, the grader might assume that your correct answer is your correct answer. So she said that she tells her students never to circle their answers. But there's also other teachers that tell their students to always circle their answers because they don't, if you do have the right answer there, they don't, the grader might miss it if it's kind of unorganized. So,
Yeah, that's what I want. My answer is look at the middle.
yeah, the way you work, Daniel, you might need to circle your answer because you're. So I can see the argument for both. I think if your work is really neat, I would not circle my answer. If you look at your work and you've kind of gone all over the place, especially if you like worked over here and then moved over here and back, and it's not really easy to follow, I'd probably circle the answer.
Like if I run out of space, I just put the equation, the equal sign on the other side of it.
And the good thing about the AP exam is they do give you, in my opinion, like way more space than you usually need. So I feel like for most of you, you'll have plenty of room. Sometimes on my assignments, I'm trying to save a little bit of paper so I don't give you quite as much room as they would there. All right, so these two parts are review stuff, right? We've already done slope fields. We've already done tangent lines. Tangent lines were a long time ago. We just haven't done them given in a differential equation sort of context yet. But part C is where you're going to actually solve this differential equation. So our differential equation was dy over dx equals y minus 1 over x. So we could cross multiply if you want. That gives you x dy equals y minus 1 dx. And so we're going to have to divide this side by x to get rid of the x. And then we'll have to divide this side by the y minus 1. Yes. So we're going to have dy over y minus 1 equals dx over x. if that was confusing to you, another way you could think about this, so I'm just doing this a different way in case that was not the way your brain works on this. If you multiply both sides by dx, like that, you got dy equals y minus 1 over x dx. And then this y minus 1 right here, you'd have to divide it off. Yeah. So that also gives you dy over y minus 1 equals dx over x. So that, yeah. You don't have to do both of those ways, certainly. I was just trying, depending on how you're thinking about it. Either one of those will work. So your first point, sometimes it's even 2 points, is going to be for separating your variables. And there will be a note on the rubric for the graders, because they've released a lot of these, that's going to say, if no separation of variables, no credit on this. So if you don't separate your variables, it doesn't matter what you do later, you get 0 credit. And usually these are worth at least 5 points. Like this one would probably be 2 points for the slope field, 2 points for the tangent line, and 5 points for this part C. So if you don't separate your variables, then you cannot get any credit for it. Get all of your x's on one side and y's on the other. So if you just like tried to start integrating from where you were at the beginning, you wouldn't get any points at all. So now we're going to integrate both sides. What do we get when we integrate dy over y minus 1? Natural log absolute value of y minus 1. What do we get when we integrate dx over x? Plus c. You can put c's on both sides, but because they can be combined just to one single into one single unknown value, I usually just put it on one side. It makes it much easier to complete the problem. The integral of 1 over x is natural log of the absolute value of x plus c. So, and over here, it is a u-du substitution right there, but the derivative, like your u right there, would be y minus 1. So your du is just, if it's anything besides just the x, then you would need to substitute there in that case. So if you have anything besides just the y. In this particular case, though, because the derivative of y minus 1 is just 1, dy, your u is just going to be what's inside of your natural log. You don't have, if that was a 2y minus 1, then our du would be 2. We'd have to put a 1/2 out front, so it would work a little bit. Okay, we okay here? Okay, so there would be a point for separating variables. There would be, depending on how they give you points on this problem, a point or 2 for taking the derivatives. Oh, not derivatives, integrals correctly. So 1 point maybe, or possibly 2 points, 1 for each side. And then what I think they'd probably do on this, because it'd probably be worth 5 points in this section, they'd probably give you a point for the integrals. They give you a point for the plus c. And if you don't put the plus c, then you cannot get any more points for the rest of this problem. And if you add it at the end like Daniel did on that problem the other day, you still can't get any points on the problem. Any more points. You could get the points for separating and for integrating, but you wouldn't get any more points after that. It is a huge deal, because if you don't have the plus c, you can't find the particular solution. Because at this point, we've got to either solve this for y or we got to use our initial condition. But if we don't have the plus c there, then we can't find the particular solution because we don't have that variable there to solve for. So I would probably on this one solve for y first because I don't like all that natural log stuff. So we would do e to the power on both sides. So on this left-hand side, I'm going to get just y minus 1. What do I have to do with this plus c right here when I do that e to the power? It goes out front, and it's going to be c e to the natural log of absolute value of x, or I don't have to write that step if I want, because what happens with that e and that natural log? Cancel, and we just get that x right there. You can drop the absolute value bars because the c can be positive or negative, so that sort of takes care of it there. And so you can move the 1 over, so y equals cx plus 1. You know that you have to solve for y because if it says find the particular solution y equals f of x, that right there is what's telling you to solve for y. So the reason that it happens is because right here you're doing e to the natural log of absolute value of x plus c. So the whole thing is in the exponent. The plus c is up there in the exponent. So you could write this like this, e to the natural log of the absolute value of x times e to the c power. And so that e to the c power is still just an unknown value, right? So we could replace it just with a big C and write it as c e to the natural log of x times absolute value of x, but the e and natural log will then cancel. So, no, because if I have something like x squared times x to the third, you add the exponents together there. So if the exponents are added, each base could be multiplied together. You don't have to show any of this work right here. If you want to, that's fine. But you can pretty much just know that if you have that plus c and you're doing that e to the power on each side, it's going to show up here as the big C. So you don't have to show the work for that. Mm-hmm. Yes. If you wanted to solve for your C, you could do it that way. So they give you f of 3 equals 2. So you got, that's the 0.32. So you could just plug those in, or like Eli has done, you solved it for C, right? And then just plug that in so you found your C. You could do it like this as well. You could do 2 equals C times 3 plus 1 and solve it that way. Either way is fine. If you do it this way, you'll get 1 equals 3C. Divide by 3. So for your C, you're going to get 1/3. So your very final answer is going to be y equals 1/3 x plus 1.
I just thought it was funny how C equals dy dx.
Yes.
So what exactly are we solving for?
It is out there. This is your final answer at the end.
Which you're finding dy over y minus 1, right?
So you're taking this, the derivative, you separate the variables. So,
By plugging in the other.
and then you integrate both sides. So,
Yeah,
now,
what are we solving? What were we trying to
we're trying to get, first of all, we're trying to get rid of the dy and dx. So to get rid of the dy and dx, you have to integrate both sides. And to integrate both sides, you'd have to separate those variables out there. So So when you have a differential equation and you're solving it, you're getting rid of the derivative part of it. Yeah. And then after that, you're solving for y, and you know you have to solve for y because they told you that you have the particular solution y equals f of x. Possibly. I'm not sure. I don't know. All right, let's look at this last. We got two more, but we're only going to have time for this example 3 right here. So the general solution to the differential equation dy over dx equals x over y is y equals plus or minus the square root of x squared plus c. And let y equals f of x be the particular solution to the differential equation with the initial condition -2, negative square root of 2. Which of the following is an expression for f of x and the domain for which the solution is valid? Okay, so they have solved the differential equation for you. You do not have to do that part. Okay, so they give you the differential equation. They have solved it for you, so you don't have to do that part. This is an example of something like you would see on the multiple choice section, because Daniel said that first one was really long. They might give you that, but they're not going to give you a ton of those. This one's going to be quicker because you've already got the differential equation. So you just have to take your point here and plug it in. So -2, negative square root of 2 is going to get plugged in. So we would have negative square root of 2 equals plus or minus the square root of -2 squared plus c. So that would give us negative square root of 2 equals plus or minus the square root of 4 plus c. And we could square both sides here to get rid of those square roots. It'll also get rid of any of the signs, so you'll just get 2 equals 4 plus c. Subtract your 4. So -2 is your c. Honestly, you really didn't have to do that part, did we? all of these are -2. So you really don't even have to do that part. So whenever we're solving here, whenever you square both sides, you're squaring that plus or minus and squaring the square root. So if you square positive, it's still positive. If you square negative, it's also positive, so it kind of goes away. But we do have to think about the domain here. So if we think about our plugging in a number, we're plugging in -2, and we see here that if we plug in -2, we're going to get negative square root of 2. Is there any way we can get a negative underneath that square root? No. So to get that negative square root of 2, we have to have one of these answers right here that has the negative. So our original had that plus or minus. You have to choose one of those. So it's going to have to be either A or C because you've got that negative that you're getting there. And then whatever is underneath the square root for a problem like this, it has to be greater than, usually or equal to, but they don't have any or equal to's here. So I'm just going to go with greater than, although I need to think about why that's not or equal to. So x squared would be greater than 2. Normally when we square root both sides, we put a plus or minus, but that's whenever we have an equal sign. Another alternative for that is putting absolute value of x is greater than 2, which is your answer choice C. Okay, so we did not get to example 4. We will try to look at it tomorrow, so don't lose it. So tonight, you have 4 questions here. You have a differential equation, which is very similar to the one that we just did on that free response. And then you've got 3 multiple choice questions that you're going to do for me there. So do that and also finish up that midterm review that we were doing earlier today.